How artificial intelligence automates real-time phishing detection and prevention tactics. For more cybersecurity tips, don't forget to like and subscribe. The split-second window. Phishing wins when it gets to the user faster than the user can think. How fast does a phishing email actually arrive? Seconds. Users read and react before any human reviewer ever sees the message. Where do humans usually fail? Most stolen passwords are typed within the first minute of clicking the bad link. Why aren't user reports enough? By the time a user reports the email, the attacker is often already inside the account. Takeaway: the defense window is sub-minute, so it has to be automated. Why static blacklists fail? A list of known bad links is always behind the attacker. What is a blacklist? A list of bad domains and senders that email filters check every message against. Why does it fall behind? Attackers rotate domains every few hours, so the list is stale before it is shared. What is a polymorphic kit? A toolkit that automatically changes the subject, sender, and links on every send. Takeaway: if your only defense is a list, you are always one step behind. Neural networks at the edge. A small AI model reads every email and grades how risky it looks. What does the model look at? The sender, the message text, the embedded links, and the path the email took to reach you. How fast is each check? Under 50 milliseconds, fast enough to run before the email is delivered to the inbox. What does the model decide? Safe emails pass through, risky ones get a warning banner, clearly bad ones are quarantined. Takeaway: every email is scored before it lands, not after a user reacts. Dissecting SMTP headers. Every email carries a hidden passport that tells you who actually sent it. What is an email header? Metadata describing who sent the message, when, and the servers it traveled through. What do SPF, DKIM, and MARC do? They are three standard checks that confirm the sender really owns the domain they claim. What signals impersonation? Mismatched display names, strange relay paths, and missing signatures are classic clues. Takeaway: most phishing fails at least one header check. AI catches that for you. URL entropy and lexical signals. Weird-looking links are usually attacker links, and the model knows what weird looks like. What does entropy mean here? How random a domain name looks. Q3x9kp.com is high entropy, news.com is not. What other link clues are used? Length, brand impersonation, and lookalike characters such as the one in paypal1.com. What is live inspection? A safe crawler opens the page in a sandbox to see exactly what a real user would see. Takeaway: a phishing site that went live minutes ago can still be caught on first sight. Behavioral modeling versus polymorphic kits. Attackers reuse the same toolkit. AI learns to recognize the toolkit, not just one campaign. What is a phishing kit? A reusable bundle of templates and scripts that attackers run to launch many campaigns cheaply. How does it dodge blocklists? Every campaign uses fresh domains, new templates, and renamed files so it looks brand new. How does AI catch the kit? It clusters campaigns by shared infrastructure and code fingerprints, not the surface details. Takeaway: catch one variant, and the system catches every variant. Real-time interception pipeline. Inbound SMTP. Pre-delivery handoff. Feature extraction. Headers, URLs, content, attachments. Parallel scoring. Header model. Content model. URL model. Attachment sandbox. Risk fusion. Combine verdicts, graduate action. Routing. Allow, banner, quarantine. Continuous telemetry daily model retraining analyst overrides end user reports. Closed feedback loop from routing back into feature extraction and scoring models. Sub 50 ms inline decision per message pre-delivery interception, not post-click cleanup. Business outcomes. What changes once AI-driven phishing defense is in place? How much faster is detection? Time to identify an attack drops from hours of manual triage to milliseconds of automated scoring. How do incidents change? Successful credential thefts fall sharply quarter over quarter once inline scoring is live. How does the security team change? Analysts stop chasing low-value alerts and start hunting more sophisticated threats. Takeaway: prevention rate goes up, analyst load goes down, audit trail gets cleaner. Key takeaways. 5 things to remember from this presentation. Why move beyond blacklists? Learning models replace static lists that go stale within hours of being published. Why score everything inline? Headers, URLs, content, and behavior must be checked before the message reaches the user. Why block before the click? Polymorphic kits should be stopped at the gateway, not after a user is already tricked. What should you measure? Prevention rate at the gateway, not just how fast you recover after a breach. Takeaway: treat phishing defense as a learning system that improves with every signal.